Alright guys, I just wanted to really quickly run through the differences between simple molecular structures and giant covalent structures. So with simple molecular structures, they're the normal covalent compounds that you think of. So if you think of something like chlorine, for example, one chlorine molecule looks like this. Alright, so here we have our two atoms of chlorine. So we have one chlorine atom and another chlorine atom. And then this thing in the middle is our covalent bond, okay? So here inside we have two electrons, and if you remember the definition of a covalent bond, it's a shared pair of electrons. Okay. Now, if I draw another molecule, we'd have something looking like this. Okay, and that's basically just the exact same thing as this over here. Okay, I've just done it twice now. And what an intermolecular force is just a force between these molecules. Okay, so inter means in between, and molecular obviously means just like molecules, right? So intermolecular means between molecules. Okay, so an intermolecular force is a force between molecules. Okay, so if I have a sample of chlorine, okay, that basically just means if I zoom into that sample, I have a bunch of chlorine molecules, okay, somewhere like thousands of chlorine molecules, and they're all joined together by an intermolecular force. Okay, so something like this. Alright, so this is what a small sample of chlorine looks like. Okay, over here. And as you can see, we've got lots of molecules that are just like this one. And they're all joined together by this intermolecular force that I've drawn in blue. So basically a sample is just a bunch of different molecules joined together by an intermolecular force. Okay, so giant covalent structures are a bit different. So with giant covalent structures, obviously it's still covalent bonding. However, instead of a bunch of different molecules joined together by intermolecular forces, okay, so I think the best way to understand it is by going through an example. So for example, diamond, okay, here. So as you can see, each carbon atom is bonded to 4 different atoms. So here you have an atom, and that's bonded 1, 2, 3, 4, right? Okay. Now notice how all of these are covalent bonds. Okay, there's no intermolecular force, okay? And that's because there's no two molecules, okay? The whole thing, the whole structure is one big molecule. So basically, if I get like a piece of diamond, it's not like a simple molecular structure where it's like a bunch of molecules joined together. It's all just one big structure. In diamond, each carbon atom forms 4 covalent bonds with other carbon atoms in a giant covalent structure. So diamond is very hard, has a very high melting point, and does not conduct electricity. Now, the reason why diamond has a high melting point is that in diamond you have to break the covalent bonds because there's no intermolecular forces, right? Now, if you go back to chlorine, for example, here, if you're trying to, this is a liquid, right? And you're trying to turn it into a gas. Okay, to separate these molecules, you wouldn't need to break covalent bonds. You would just need to break these intermolecular forces here, and then the molecules separate. So if I break all these forces, for example, then this molecule here is separated from all the rest. Okay, and you would do that for all of these forces, then the whole structure breaks, right? So you don't need to break the covalent bonds. Now, breaking the intermolecular forces is a lot easier than breaking the bonds, so it takes a lot less energy. Okay, so typically simple molecular structures have a lower melting point. In graphite, each carbon atom forms 3 covalent bonds with 3 other carbon atoms, forming layers of hexagonal rings, and so graphite has a high melting point. The layers are free to slide over each other because there are no covalent bonds between the layers, and so graphite is soft and slippery. Okay, so I said usually there's no intermolecular forces, right? However, in graphite there is, and that's because graphite is basically a bunch of layers on top of each other. So if you imagine like a page here and another page here, then there's a force in between them, okay, and that force is intermolecular, okay? So because these forces here are intermolecular forces, like that, they're really weak, So essentially this layer can really easily slide over this layer, okay, because those forces are weak. In graphite, one electron from each carbon atom is delocalized. These delocalized electrons allow graphite to conduct thermal energy and electricity through the structure. Graphite is similar to metals in that it has a delocalized electrons. Now you also need to know what graphene is, which is just a single layer of graphite, and so is one atom thick. So essentially, it's just like this bit, okay, just one layer of graphite. Alright, so that's the difference between giant covalent structures and simple molecular structures. Now, be sure to remember these three examples that I've given: diamond, graphite, and graphene, because they can ask you about that in your exam. Alright.